How do we find the degree of freedom of a mechanical system? Using Gruebler's equation, which is 3 times n minus 1 minus 2 times j1 minus j2. Here n is the number of links, j1 is the number of lower kinematic pairs such as a revolute pair, prismatic pair, screw pair, cylindrical pair, spherical pair, and planar pair, which has a surface contact. And j2 is the number of higher kinematic pairs, which means you only have a line contact, like gears and cams. And here in the video, I will show you, simple linkages. For example, you have a simple link with 2 nodes, you have a complex link with 3 nodes, and you have a slider. So here you see the restrictions. And also, from here, if I go back, you can design a mechanical system using those simple links. Here we are going to use those linkages to create a mechanism. And this mechanism's output is the slider, which moves back and forth. Going back to the theory, knowing the equation and knowing the terms, let's find the degree of freedom of these 4 mechanisms here. So the Gruebler's equation was 3 times n minus 1 minus 2 times j1 minus j2, starting with the number of links. So here, all the fixed points will be counted as 1. So I have 1, 2, the order really doesn't matter, 3, 4, 5, and 6. So here n is equal to 6. Let me change my color. Now let's calculate the number of lower kinematic pairs. That means like ball bearings. There is 1 here, the second one, the third one. So this is very important. This bearing connects 1, 2, 3 linkages. So it will be counted as the number of links connected together minus 1. Because 3 links are connected at the same joint, it will be 2 lower kinematic pairs. So because I have here 1, 2, and 3, I should continue with here 4 and 5. Then number 6, and here is 7. So the number of lower kinematic pairs is 2. Let me change again my color to blue. J2 is when you have a contact, when you have a line contact, such as this point here only. So there's only one higher pair kinematic joint. And if you do the math by plugging in these values into the equation, degree of freedom will be 3 times 5 minus 2 times 7 minus 1. So degree of freedom should be equal to 0. So if the degree of freedom is equal to 0, you actually did not design a mechanism, but you designed a structure. Let's continue with the second example here. Remember, please, all the fixed points will be counted as one link. So I have 1, 2, and 3. Let me type in the equation. Degree of freedom is calculated by 3 times n minus 1 minus 2 times j1 minus j2. And here we have 3 links. And continuing with the number of lower pair kinematic joints, we have 1, another one here, and this is only a point contact, so it's a higher pair. So j1 is equal to 2, and then j2 will be just equal to 1. So from here, degree of freedom will be equal to 3 times n minus 1 minus 2 times j1 minus j2. So degree of freedom is equal to 1. Because it's greater than 0, you designed a mechanism, just 1 degree of freedom mechanism. And number 3, the third example here, the degree of freedom is 3 times n minus 1 minus 2j1 minus j2. Here, starting with the number of links, start always with the fixed link, so not to miss it off, while counting the number of links. So we have 1, 2, 3, and the slider is also counted as a link, so it should be number 4. So we have 4 number of links, and then we will count the number of lower pair kinematic joints. So here is 1, 2, 3. Now I'm going to be careful because the slider is also a joint. So the slider is constrained within the rail, so it should be also counted as a lower pair. And in this example, we don't have any higher pair, like cam or point contact or gears. Then the degree of freedom should be 3 times 3 minus 2 times 4, which is 1. So this is actually a mechanism, not a structure. Degree of freedom for the last example, typing the equation first, and then counting the number of links. I will always start with the fixed or grounded links. So 1, 2, 3, 4, 5, 6, and 7. 7 number of links. Then we have lower kinematic pairs. 1, 2, 3, 4, 5, 6, and 7. So you probably wonder why didn't I count this one as J1. Let me first put the number of lower pair kinematic joints and then continue with J2. This is not a ball bearing, so this is like this will create a point contact on both sides of this slotted link here. So this will be counted as a higher pair kinematic joint. Then the degree of freedom should be equal to 3 times 6 minus 2 times 7 minus 1, which will be equal to 18 minus 15, which is